Hello friends, I am Nirav Parikh and I welcome you all to the today's session of probability. Today we will be discussing the basic definitions of probability and take a few examples and understand them. Okay, starting with the basic terminology, event. An event is an outcome to a random occurrence. For example, if we toss a coin, it is an event because the outcome of the event is random. So either a head or a tail could come when we toss a coin. Probability. It is the likelihood of an event occurring. For example, we say there are 70% chances of having a rain today. So this is an example of probability. In probability, we'll discuss few basic terminology, starting with intersection of events. Intersection of events is when both the events occur simultaneously. That is, suppose we have two events, event A and event B, and both the events should occur simultaneously. That is intersection of events. Union of events. Union of events is when either of the events could occur. So if we have two events, event A and event B, either of the events could occur. Taking an example of intersection of events, the keyword for intersection is and. So the term should be present. So the term should be present for in both event A and event B. For example, event A is rolling a dice to get an even number. When we roll a dice, we could get a 2, a 4 or a 6. So that is an event A. Event B is rolling a dice for an odd number, let's say. Then the possibilities are 1, 3 and 5. So the intersection of events A and B would be a null set. Union of events. The keyword for union of events is or. Whenever we have when we have a possibility of either event A or event B occurring, then it is a union of events. For example, let's assume an event A which is rolling a dice to get an even number. So the possible numbers we can get is 2, 4 and 6. Let's assume an event B which is rolling a dice to get a prime number. We can get a 2, a 3 or a 5. Only element 2 is common with event A and event B. Hence intersection of events just have only one element in common. If we combine these two events, then it would be a set of 2, 3, 4, 5 and 6, which is union of events. Moving on to independent events and dependent events. Independent event, as the name suggests, when an event is not dependent on any other event. For example, tossing a coin. If we toss a coin, we can get either a head or a tail. Let's assume we tossed a coin and we got a head. Now if I again toss the coin, we can either get a head or a tail with equal probability. So the first event of getting a head did not affect my second toss. So independent events are not dependent on any other events. Similarly, independent events are dependent on other elements. For example, I have 10 balls in a bag. If I draw one ball out of the bag, and if I try to draw second ball after drawing the first ball, then the probability of the second ball would be affected as the first ball has been drawn out of the bag. For example, a bag contains 4 blue balls and 5 red balls. The event of selecting a blue ball after you have drawn a ball without replacement. In this case, we have in all 9 balls. So the probability of drawing a blue ball would be 4 by 9. And since we are drawing a ball without replacement, this event would be dependent on the ball that we selected first. Mutually exclusive events. Two events which have nothing in common. So if for example, let's take an example of a dice, and event A, that is rolling of an odd number, is equal to 1, 3 and 5. event B rolling the dice to get an even number, that is 2, 4 and 6. If I take intersection of these two sets A and B, we have nothing in common, since odd numbers are 1, 3 and 5 and the even numbers are 2, 4 and 6. So they have nothing in common, hence the intersection is a null set. Whenever two sets have nothing in common, they are called mutually exclusive events. Now we'll discuss mutually exhaustive events. The previous example, the example we just discussed, when we take a union of events A and B and all the elements, possible elements are included, then it is mutually exclusive events. Whenever we roll a dice, we can get either a 1, 2, 3, 4, 5 or 6. So in this case, if event A, which is rolling a dice to get an odd number, and event B, which is rolling the dice to get a even number, when I combine all the elements of event A and event B, I get all the possible elements. Hence set A and set B are said to be mutually exhaustive events. Now moving on to the universal set. Universal set is a set of all possible events occurring. For example, for a coin, a head and a tail. These are the two possibilities which consists of the universal set. Dice, for dice 1, 2, 3, 4, 5, 6. These are the possible elements. For cards, there are 52 cards and there are 52 possible elements. Complement of an event. Complement of an event is nothing but the set of all elements other than the elements present in event A. For example, rolling a dice again for an odd number gives me a 1, 3 and a 5. So complement of this event A would be 2, 4 and 6. Similarly, let's take another example, again rolling a dice to get a prime number. Prime numbers are 2, 3 and 5. The complement of this event A, which is the set of all prime numbers, is 1, 4 and 6. Now probability. We have discussed some of the events and basic definitions of probability. Now we'll move on to the mathematical definition of probability. What is probability? Probability is nothing but a ratio of number of favorable outcomes of A upon total number of outcomes. Example, event of rolling a dice to get a prime number. The total number of outcomes while rolling a dice are 6. That is, we can either get a 1, a 2, a 3, a 4, a 5 or a 6. So the total number of outcomes is 6. Number of favorable outcomes. Since the event A asks for a prime number, the prime numbers are 2, 3 and 5. So the total number of cases is outcomes is 6 and the total number of favorable outcomes is 3. So total 3 by 6 would give me the probability, that is 0.5, 50% chances of getting a prime number. Another example, probability of getting at least one head when an unbiased coin is tossed twice. So we are making two tosses of a coin. So the possible outcomes could be 2 heads, 2 tails, a head and a tail, or a tail and a head. In this case, the probability of getting at least one head is, out of the given 4 cases, there are 3 cases which satisfies the given event. So the total number of outcomes is 4 and the favorable outcomes is 3. Hence the probability of event occurring is 3 by 4, that is 75%. Let's take another example. A bag contains all the factors of 32. What is the probability of getting a factor of 36? Now first we need to break the number 32 and find the factors for number 32. The factors are 1, 2, 4, 8, 16 and 32. Total 6 factors. These are the numbers that are present in the bag. So in all there are 6 factors in the bag. That is my total number of outcomes. Now I need to know the factors of 36, because the question asks the probability of getting a factor of 36 out of the bag. The factors for 36 would be 1, 2, 3, 4, 6, 9, 12, 18 and 36. These are the factors for 36. Of these factors, 1, 2 and 4 are there in the bag, whereas factors 6, 3, 12, 18, 9, 36, these are not present in the bag. So there is a probability of drawing either a 1, 2 or a 4. So total number of elements is 6, whereas there are 3 factors of 36 present in the bag. So the probability of finding a factor of 36 is 3 by 6, that is again 0.5, that is 50%. Probability. A couple of important facts about probability. Probability at minimum could be 0 and at maximum could be 1. Probability always lies within the bounds of 0 and 1. Probability cannot be less than 0, that is it cannot be a negative number, and probability cannot be greater than 1, that is 100. If a probability is 0, then we say event will not occur. If we say probability is 1, we say event is sure to occur, that is there is 100% probability of an event occurring. Also, total probability cannot exceed 1 for all the events. Now we will take a look at the conditional probability. Conditional probability is nothing but probability of an event occurring after another event has occurred. So the probability of an event A occurring after another event B has already occurred. So the formula for it would be probability of A slash B is equal to probability of A intersection B upon probability of B. Let's discuss each of the terms of this formula. The first one, probability of A slash B is equal to probability of event A occurring after event B has occurred, that is the conditional probability. Probability of A intersection B is equal to probability of event A and event B occurring together. As we previously discussed, intersection is nothing but two events occurring simultaneously. Now probability PB is equal to probability of event B occurring. Taking an example, the probability of choosing a red marble is 0.4 and the probability of choosing a red and a blue marble is 0.3. What is the probability of choosing a blue marble after choosing a red marble? Event A in this case would be probability of choosing a blue marble. Event B in this case would be probability of choosing a red marble, that is given, which is 0.4. Probability of choosing A after an event B has already occurred is equal to probability of choosing a blue marble after choosing a red marble. PA intersection B is again probability of choosing red and blue marble together, that which is in this case 0.3. So probability of A occurring after the event B has already occurred is PA intersection B upon PB, which is equal to 0.3 upon 0.4 is equal to 0.75%, which means there are 75% chance of choosing the marble, blue marble after having chosen the red marble. Now conditional probability. While we were discussing this conditional probability topic, we implicitly made one assumption. The assumption was that event A is dependent on event B. That is, while we were choosing a blue marble, we implicitly assumed that the choosing of a red marble would impact the choice of a blue marble. So when if events are dependent, we will use the formula that we just discussed. What if the events are independent? In that case, occurrence of an event would not be affected by the occurrence of another event. So if we are trying to find the conditional probability of event A occurring after event B has occurred, then probability of event A slash B is nothing but probability of event A occurring, since A and B are independent events. Similarly, probability of event B occurring after event A has occurred is probability of nothing but equal to probability of event B occurring. Thank you.